Alright guys, so today we are going to be doing a lab dealing with limiting reactant. So we're going to do a reaction, we're going to keep track of how much of my ingredients, how much of my reactants I've got for both, and then we're going to see, theoretically, how much we should be able to make, and then experimentally how much we actually make, and then check with the percent yield. So we have our balance to keep track of our mass, we're going to keep track of our solution, or we're going to do our reaction in this little beaker. And this reaction is going to be between aluminum foil, in other words just straight aluminum, and copper 2 chloride. So you'll notice it has the formula weight on there as well, the 170.49. That might be helpful later on, but we're going to do a reaction between those two things. Alright, one of the first questions you're going to be asked is to write the full equation, the balanced reaction between these two things, the aluminum and the copper 2 chloride. Now you'll notice that one of the products that will be formed will be a solid. So what we're going to do in this reaction is we're going to complete the reaction, and when we're done we want to know exactly how much of our product did we actually form. So that's why we're going to use this thing right here. This is a filter paper. So what we're going to do is we're going to pour our solution through here, and we're going to collect it, and we're going to see how much is left over. In order to do that though, I need to know the mass of my filter paper to start with, and then the mass at the end so that I can subtract. So I'm going to go ahead and keep track of all of my measurements here. So my filter paper is 1.49. I'm going to go ahead and do my aluminum next. Aluminum is going to be 0.60 grams. And then for my copper 2 chloride, it's going to be a little tricky. There's a couple ways you can do this. The easiest way that I'm going to do it is just to put the beaker on, zero it out, and that way when I add my copper 2 chloride, I know that that is exactly what I'm adding. The lid just gave me a little bit of trouble. So here we go. I'm going to add a little bit here. I'm going to add a good bit of copper. So that's 2.6 grams so far. I've got a number in mind, but it really doesn't matter exactly how much. Oh, that's going to be plenty. Okay, so notice how fancy and how precise I was with my adding. In this case, the exact amounts aren't super important, but we just want to make sure to write them down exact. So 6.35 grams of copper chloride. Okay, at this point, I have all of the measurements. Now I can do my reaction. Okay, so I've got my copper chloride right here. I'm going to add a little bit of water to this. Okay, a little bit of water. Stir it up, make sure all that copper chloride dissolves. A few chunks there. And now for this reaction to happen, I'm actually going to have to add a little bit of a catalyst here, which is why I've got this mysterious bottle over here with hydrochloric acid. So I'm going to be adding a drop of this just to help it break down, because on our aluminum foil, there's a little bit of a sheen, a little bit of a coating on this to keep it from reacting. So it's just going to break that down and help our reaction occur. So let me stir a little bit more. Okay. Put that to the side. Now all I'm going to do, add my drop of hydrochloric acid. Let's do 2 drops actually. Okay. 2 drops hydrochloric acid. Stir that up just a hair. Okay, now I'm going to crumple up my aluminum foil just a little bit, nothing too crazy. Alright, and let's just plop it in there, and let's see what happens. See if there's a chemical change. Alright, so you should be seeing a chemical change occurring. What do you notice? Think about some observations. What are some signs of a chemical change? I don't really have to do too much to this to help it along. Guess that hydrochloric acid is doing the trick. I can tell you it smells lovely. Alright, so I'm going to let this sit for a while, but let me just hold it up for you. Okay, and, ooh, it is quite warm. So what I'm going to do is I'm going to let this set, and then I'm going to filter it. I'll show you the filtration setup, but essentially it's going to get to go through this. Okay, I've waited for a moment, and now our substance, our solid, has settled to the bottom. You'll be able to get a good look at this in a minute. But now let's set up our filtration device. I have an Erlenmeyer flask below just to collect the liquid, but I'm not really concerned about the liquid. I just want to get this solid, the chunky solid that's in the bottom, which is why I use the filter paper. So if I fold it in half, fold it in half again, okay. Now, if I take 3 in 1, I have this nice little pouch. Okay, so this pouch fits neatly into my funnel. Now, if I don't do anything, it pops out. So I have a little wash bottle here, and it has a little bit of deionized water. So regular water that we can put, and it's not going to be an issue. If I just do a little bit around the sides, it sticks. Okay, it stays much better. At this point, I'm just going to go ahead and pour in all my substance and let that drain through. That liquid's going to go through, and we're going to be left with our solid. Now you'll notice when I poured at first, it leaves this solid behind, okay? That should look familiar, right? Think about what product should be formed. So I'm going to let this drain a while, and then I'm going to rinse this out, and I'm going to pour everything in, and I'll show you the finished product. Okay, the last thing I'm going to do is I'm going to remove my filter paper, and at this point, we can see that we've got all our solid in here. Yum, it looks delicious, right? I'm kidding, don't actually eat this, right? And so at this point we should have just copper, but there's also a lot of liquid. There's a lot of water in here. So what I'm going to do now is I am just going to leave it right here, and I'm going to let it dry probably overnight, and then I will record the mass. I will give you the mass in the data table on your lab. Okay, so go ahead and answer the questions for the lab portion, and then the questions afterwards as well.